Alright, so today let's look at how we can create an adaptive component whose geometry can be manipulated through Dynamo. So we'll start off by creating a new family. And the family template that you want to select is going to be this generic model adaptive here. We'll say open. Once you reach this window with the different reference planes here, the first things we're going to want to do are make sure that we have the XY plane selected. By default it should be, and then we'll go ahead and place several point elements on that plane. In this case I'm going to be using 4, so we'll use a rectangular panel, creating a rectangular panel. So the reason that we're actually doing this with adaptive components and points versus a curtain panel pattern based is that we're actually going to pass these 4 points in through Dynamo and use Dynamo to actually place our geometry for our adaptive component. So let's start off by selecting each one of these points that we've created one at a time and make them adaptive. And what we want to do is we want to choose a direction either clockwise or counterclockwise and move the whole way around one at a time. So you see now that these are numbered 1, 2, 3, 4. Alright, now that we've done that, we can quickly create an outline for our panel by holding Control and selecting 2 of our points at a time. We can click on Spline Through Points to create a line between them. I find that this way works well because we know for certain that we're referencing the points that we want to reference with each one of our lines. You can ignore any little warnings that you get that it might not determine a plane as long as you have selected that. Whoops. As long as you selected that bottom plane, they should be planar. Okay, so when it tells you the geometry doesn't determine a plane, it just means that this might be slightly off axis from actually being 90 degrees. Alright, so now we have our set of lines that are connecting these points. If we click, it should highlight all 4 of them. We can come over into the Properties window and select Is Reference Line and say Apply. You should see that when you click off now the lines have turned green. So now this means that these are not lines that are to be actually drawn or included as part of the model. They're a reference line for another geometry to be built off of. If you can't see your properties window, just really quickly you can go to View, User Interface, and check the Properties box here. Okay, so now that we have our reference lines for the outline of our form, we can come in and we can actually place a series of points on one of our reference lines. We're going to place 2 points, and we'll click just right on the green line. You should see it highlight when you hover over it. Alright, once we have those points, if we hover over them, we should be able to select them individually and see that they have a reference plane that is perpendicular to the direction of our reference line that they're placed on. By default, this reference plane will be vertical. We can see that it remains vertical for the other point as well. If you're having trouble selecting these, you can click Tab to toggle through the possible selections for any point where your mouse is located. Alright, so next thing we want to do is take a look at some of the settings for these and understand how we can build geometry based off these points that are hosted to our reference line. So just looking at some of the different options for the point geometry, we see that point geometry has a rotation angle, so we can play around with that a little bit. If I put in 45 degrees and press enter or press apply, we can see that it rotates 45 degrees. So I'm just going to set that back to 0, say apply. The other thing we can look at is that each one of these points has what's called a normalized curve parameter, and this is essentially the percentage of the way along its reference curve that it occupies. So we see that this point is currently located at 14% of the way through this reference line. So if we click on the other point, you can see its normalized curve parameters at essentially 88.5% of the way along the reference line. So that normalized curve parameter can help us to adjust the location of these. So let's start building a little bit more geometry based off of our points that we have now. What we're going to create is a louver that we can adjust the rotation of and the depth of for our adaptive component here. So what I'll start by doing is setting my reference plane, and I'll select that point, and by doing that I'm telling the system that I want to draw on that reference plane that is perpendicular to this reference line here. And then I'll go ahead and draw a line, so I'll come up here and click on line, and you can see that it highlights this blue plane for our current work plane or reference plane. And so I'm just going to, it should snap to vertical, and really this is a much larger panel than I need it to be, but for the sake of being able to see it, I'll keep the panel around, we'll say 14 feet. You can really enter anything you want. We'll modify this later. And then what I'll do is I'll come over here and say set reference plane again, and I'll click on the other point. You can select draw a line and do exactly the same thing we've done in the previous one. Okay, so now if we click on these different lines that we've drawn, see that this little measurement pops up, and we can click on the icon to make the dimension permanent. Do this for both. And now we have the ability to adjust the size of the size of these different pieces. So what we want to do is we want to make these into reference lines, because we're going to use these as the edges of our louver geometry. So I'll click on both of them, and I'll come over here just like we did before and say is reference line. Okay, so once those are reference lines, we can go ahead and select both of them by holding down Control, and then we can say create form. And you should see that there's another option that pops up in the bottom corner here. If not, you can press spacebar to toggle through the different options for what geometry you need. And the one we want is just a straight loft essentially between these two lines. I'll press enter. Alright, so you can see now that we've created a lofted plane between these two lines. This is going to essentially be our basic louver. So now let's look at how we can start to make this more parametric and add some different properties that we can manipulate later in Dynamo. So we'll come up here to the Family Types panel. We'll click on this. And in Family Types, we have, this sometimes looks a little bit differently or different in different versions of Revit, but we have the ability to then add a new parameter to our family. And what we want to make here is a parameter for the angle of rotation for our panel, or for our louver, excuse me. So we'll just simply call this angle, and we'll say its discipline is common. The type of parameter is going to be an angle, and we'll keep it grouped under dimensions. And because we don't want all of our panels to have the same type of value for this angle, we want every panel to be able to individually vary. We're going to make this into an instance parameter. So instance parameter will allow each instance of, or each instance of this panel in the project to have a different value for this particular variable. Reporting parameters are another type that can be used to make measurements. So you can make a measurement from one parameter and then use that to drive the value of another parameter. But for us, we're just going to use instance here. So we've created our angle parameter. We'll say OK. And so we can say this has a default value, and I'll just change it to 45 so that we can see when we assign it that it's working. I'll create one more parameter here, and we'll call this one depth. And for this one, we'll make it a type parameter because we're going to have all of our louvers in this case be the same depth. You may want to make this an instance for yours, but for now, I'll create this as a type. And this can be a length parameter because it's just going to be what we're going to set the length of the louver to. Okay, so I'll say OK. And currently our louver depth is 14 feet. So I'll just make this something a little bit different. I know 20 feet is huge, but it's the size this is right now. So we'll say apply. Okay. And so now we have these two parameters that are part of the project, but right now they're not assigned to anything as far as the geometry goes. So let's look at how we can start to assign those. We can click on the actual dimensions here, and you'll see that we have this option up here called label. Now on your machine you may see it also down here in the green bar. It sometimes is located here and other times is located up here. So we can go ahead and click the drop down and we can see the compatible parameters that we've created. Our parameter depth, being a length parameter, is appropriate to be set to one of these values, so we can click on that one. Okay, so you can see that that's adjusted now, the size of our panel, or the depth of our panel. So let's go back and look at how then we can create that rotation by setting our parameter value for our angle to the rotation value for these 2 points. So if we come back and click on our 2 points, we may have to tab through and hold Control to click on them. We can go over here and look at its rotation angle value, and we can actually click this little box to the right and it allows us to set the angle. We'll say OK, it's OK, and you can see now that we've rotated the planes for our points, and by doing so also rotated all geometry that references that plane. Because we drew that line that we used to loft our surface from on that plane, everything else moves. So we have our adjusted geometry based off that rotation. Okay, so now we want our louver to go from all the way from one edge of our panel to the next. So we can go back now and look at that other parameter we saw before, which is the normalized curve parameter for this point. So I can come back in here. Oops, actually we're not going to set that to a value of a parameter. We can actually just type in what we want here, since these ones we know we always want to be one all the way at the beginning of the curve and all the way at the end of the curve. So I'll press OK, and you can see that that's now moved all the way to the far edge of the reference line, the very end of the reference line. So I can do the same thing here, except for this time I'm going to type in 0 because I want it to go all the way to the beginning of the reference line. Alright, excellent. So now we have our louver, whose geometry is driven by our 2 parameters. Just to make sure everything works, we can come up here and we can change our parameters. So I can say 40, and let's try this at 60 pi, and we can see that our panel has changed angle and gotten longer. Last thing I'm going to do to finish this off is I'll click on the outer perimeter of our panel, and I'll just say create form one more time, and either press spacebar or select down at the bottom these from the 2 options. I'm just going to create another flat plane, and this will be essentially the window plane or the window panel. If you'd like, you can add in a material to that by coming up to our family types parameters and adding a new parameter. We'll call this material, and the type of this parameter is a material, and this will be a type parameter since all of our panels will have the same material. And I can set this now, set its default material. I'll select glass, say OK, apply, OK. I can click on then my plane that I've created and come over here and assign that material variable, or the material parameter that we've created, to that plane. Alright, so this has been a tutorial looking at the way that we can create generic models which are able to be manipulated in Dynamo by adjusting their parameter values.